Hello and welcome to Starborn Science. Today we will be making a complex of copper salt named copper Tetrammine Perchlorate. Now this salt has some unique properties that other salts do not have, like its tendency to, how do I frame this in order to avoid problems? Well, a tendency to violently expand from a solid to a gas in a supersonic rate, creating a shock front that propagates through the air, causing damage to surrounding structures and surfaces. Yeah, that's how I should describe it. So, let's begin the synthesis, but a little bit of theory before we do that. Sorry, let me just explain. So, as with cobalt, as we've seen already, copper exists as a high hexahydrate, meaning it has 6 water ligands. Now, if ammonia is added, ammonia has a higher affinity than water, so it replaces the water molecules with ammonia molecules. However, not all of the waters are replaced. 4 of them are replaced and 2 remain, and this forms the tetraamine diaqua water complex. However, that's one part of the coin. The other part is the anion. This is the cation, the positive ion. In this case, the anion is the chlorate ion. This ion. Now this ion has its chlorine atom at the +7 stage. Now chlorine at the +7 stage does not like being there. It likes to rip electrons out of anything. So yeah, it likes to be reduced. Oxidizers get reduced and fuels get oxidized in a redox reaction. Fuels are oxidized, oxidizers get reduced. So, in the right conditions, the ammonia ligands can act as fuel and be oxidized by the chlorate ions that are bound on the copper. So this could result in a sudden violent supersonic expansion of gases that creates a shock front that travels through the air, resulting in damages in surrounding structures. You know, I can't say anything else because of the algorithm. So, you who know, you know. So, over here I have added 2.5 grams of copper oxide. Copper over here is its +2 oxidation state. Now I will add 7.5 grams of ammonium perchlorate somehow. Yep, I added it. And now I will add 50 milliliters of concentrated 25% ammonia solution. These chemicals, I must say, are reagent grade. They are not technical grade. So that's all. That is all the basic reagents. Now I will start stirring and heating the mixture, and I leave the camera rolling so you can see the beautiful transformation of a black sludge to a pristine blue transparent solution, which is, in my opinion, really beautiful. So yeah, I will leave it over there. Maybe I will time lapse it on the video, I don't know, but yeah, let's see what happens. Oh, and this thing that says water for injection, by the way, it's not saline water, it's pure water for dissolving pharmaceutical drugs, and I use it as distilled water to wash things. Do not use water for injection to wash things, as it contains sodium chloride as an isotonic solution. Just a reminder. Yeah. So now I am filtering it, and as you can see, when I'm pouring the solution in the filter, what comes down is a oopsie. Can't do this like that. Have to be over here. So you can see a clear blue liquid, which is our complex. Now the reason this is dark is maybe of some particles of unreacted copper oxide. I suppose. Oops. Sorry for that. So yeah, I'll filter it and I'll be back. So after filtering, as you can see, this is the solution of, it's hot yet. This is the solution of copper tetrammine perchlorate. Now we will take advantage of something called solubility. Now solubility is the ability of something to dissolve in something. Now the solubility of copper tetrammine perchlorate is really high in hot water and moderate in room temperature water, but it's extremely low in low temperature. So I'm gonna cover this now with some nylon, you know, plastic, so I don't stink up my whole fridge, and put it in the freezer, and we will see in a while lots of crystals precipitating out of it, and it will be beautiful, I promise. Hello, so after leaving the solution overnight in the freezer, as you can see, we have a very clear solution on top and a mass of crystals on the bottom. Now I'll proceed to filter those crystals and try them. And here, as you can see, are our beautiful crystals. Now I will proceed to wash them with isopropyl alcohol to make sure that there are no organic impurities in there, as organic impurities and strong oxidizers do not mix very well. And then we will dry it. Look at these beautiful blue crystals. Remember what we started from, that black sheet. Oops, I said sheet. Oh well, I don't care. Yeah. Oops, forgot to turn the heat, the hot plate on to dry it. Now it's drying. So yeah, look at it, guys. It's beautiful. But behind this beauty lies a monster. Don't let its beauty fool you. This compound has about the same energy as PETN, and certainly more energy than TNT. And its VOD is about 8 kilometers per second. So it's not something to be laughed at. However, here we will be exploring mostly properties like spectroscopy, open flame tests, maybe a little of violent supersonic decomposition at a milligram level scale. Yeah, maybe a hammer test. Yeah, maybe we'll go there. But yeah, you know, that's a maybe, you know, because I don't want my channel to go, you know, down. So I don't want to be a coward too, you know. So no pain, no gain, I guess. We'll see. Enough of me yapping. So I'll write, and then we'll see what we'll do. And here we are, guys. Now let's test it. So this is what we've made so far. We replaced 4 water ligands with 4 ammonia ligands, and we have added 2 perchlorate anions to the tetrammine diaqua copper complex. Now I have about 50 milligrams of the complex on this spatula, and I'm gonna light it so you see how reactive this compound is on itself, never mind mixing it with a fuel. So as you can see, this compound is not to be messed with. It's a very serious energetic compound, and should be handled with extreme caution. So yeah, now I will take a random small quantity. We will measure it, of course, and it weighs out at 156 milligrams. Yes, that's logical. It's not anything crazy. And what I'm going to do now is wrap that in tin foil and pack it like that, and tape it on the back of my hammer and strike it on a metal plate, and well, you know, it will violently expand from a gas, from a solid to a gas, in a supersonic rate, propagating, making a shock to propagate through the environment and the surrounding structures. Yeah, you get the point. Now, I may be talking loudly, but I have plugged my ears with cotton. So, 1, 2, 3. piece of shrapnel got my finger. Holy shit! The tin foil became confetti, you guys. Holy mother bitch. That was insane. Yeah. That was insane. I got bits of aluminum embedded in my skin. I need to pull them out with tweezers. That was fucking crazy. Holy fucking shit. Yeah, I'll have to cut the video here. And yeah, I hope you enjoyed this episode of Starborn Science. I really enjoyed it as well. Keep dreaming, keep exploring, keep asking questions, and I will see you on the next one, hopefully.